My name is Mike Havey. I'm a Senior Solutions Architect with Amazon Web Services. And I'm here today to talk about multi-modeling. My session is called Multi-Model and Ontology for Every DB on the Truck. At Amazon Web Services, I work with Amazon Neptune, which is a managed graph database service. And my topic today is actually related to Neptune as well as to Knowledge Graph. So my agenda is to begin by talking about why customers would use multi-modeling, and in doing so, really describe what multi-modeling is, and to look at old school approaches to multi-modeling, how people have done it in the past. But then I want to look at what's on the truck in terms of what database services are available today. The choices are many and various. So if I wanted to leverage many of these services, I could come up with more elaborate multi-model solutions. And that gets us to thinking about what tomorrow's multi-model would look like. Then I want to show how to draw and really how to represent a multi-model solution using an example that involves movies. And I'll conclude with a summary and a call to action. So in terms of why I would want to use multi-model, let's consider a solution one might build around customers, where you would want in the same solution to represent a customer record as well as customer relationships. To build this, I might use two separate models. I might use an RDBMS or a document store to represent the customer record, but I might use a graph database to represent the customer relationships. And neither quite stands on its own. Graph is great at relationships, but it would not be the suitable place to maintain the customer record. But the RDBMS or the document store, although it's perfect for the customer record, it's not very powerful at managing customer relationships. So it's really by combining two models into one that I come up with the solution that I'm really interested in building. And in fact, there's a famous pattern that describes this called polyglot persistence. And there's a link here to Martin Fowler piece on this pattern. And the idea of the pattern is that an enterprise uses different database technologies as part of the same solution, where they choose the database technology that best fits the usage pattern. And it's by combining them that you end up with a solution. So if I wanted to consider polyglot or multi-model, it's never been easier because the number of choices that are available today in terms of database technologies is greater than ever. So an example of an old school multi-model solution, it might be building a trade based on both a document model and a graph model combined into one. And in fact, there are database vendors that support both of these models together in the same database instance, and the data can coexist with each other. So on the left, we see a trade represented overall as a JSON object, and it has both trade details such as asset class, instrument type, different prices of the trade, as well as a graph section where you would maintain triples representing relationships that this trade may have to other business objects like parties, counterparties, instruments, and so on. So we see a mixture of document and graph together in the same model. And since both of these exist within the same instance, we can actually insert both types of data together in one transaction. So we have a combined write. We also have the ability to query in combination. So we could query the JSON aspects of the data as well as the graph together in one shot. So for example, we might want to find a trade where the asset class is option, the opening price is greater than 130, and the trade, the counterparty trades might match a particular currency, for example. So we're running a combined query that's querying both the document-oriented parts of the model as well as the graph parts of the model. And there are pros and cons of this approach. To be sure, the pros are that the database ends up being a one-stop shop where I have multiple models all in one instance, and that's a tremendous convenience. The cons are that as I consider more and more models, I'm limited by what the instance would offer. And if it didn't have everything I wanted, would I really want to expand the existing instance to just tack on additional model types? In fact, if I needed lots of models, if I wanted to build a really ambitious solution, would I want to use a one-stop shop anyway? I might actually consider rather a looser coupling, a non-monolithic approach where I actually use multiple database services and string them together. So that gets me thinking about what's on the truck. What are all the database services that are available to me on the marketplace today? In fact, there's a lot of them, and cloud service providers offer them. And if we even look at just AWS by itself, we have a lot of choices. So in the figure on the right, we see that we have data lake type services with Athena, Glue, Lake Formation. We have data warehouse with Redshift. We have Neptune, which I mentioned, as a graph database. TimeStream is for time series. We have OpenSearch as a search index, Elasticache as a cache or an in-memory database. Keyspaces as a Cassandra compatible database service. DocumentDB is a Mongo compatible database service. We have relational with RDS and Aurora. Dynamo is a key value pair database. QLDB, or the Quantum Ledger database, is suitable if I want to build business objects with immutable history. And then we also have object storage with S3 and Glacier. So even within the AWS realm itself, we have many, many choices. Now, we don't want to go overboard. If I'm looking at multi-model, it means potentially several moving parts. We want to resist building solutions that are like the Rube Goldberg machine, which is an intentionally humorous attempt at building something that the humor really lies in the fact that it's far too elaborate. So I won't go through this picture in much detail, but this is a famous picture of a Rube Goldberg where a man is looking for a self-operating napkin. When he raises the spoon, as he's drinking his soup, he wants the napkin to basically wipe his mouth. And the way this will work is that when he raises the spoon, it will cause a ladle to fire a cracker into the air. The bird will chase after the cracker, and I guess that will spill some of the seeds into a bucket, which will burn the string that holds the rocket in place. When the rocket flies into the air, the hook on the end of the rocket will catch the pendulum arm of a clock, which holds the napkin, which will wipe the man's mouth. So I want to build something fairly elaborate, and my example will be movies, and it ends up being really a sensible thing to build, and we'll build it in a sensible way. And it won't be at all like Rube Goldberg, but it does end up having a lot of moving parts. And that's typical of multi-model. So let me walk through this real quick. We have a movie solution where on the kind of middle left is a movie document store that will be our system of record for movies. And the heart of this solution will be a DocumentDB database built on Amazon DocumentDB. So this will be a document-oriented approach to managing movie data. But we'll also keep a cache in front of it built on Elasticache. And we'll also supplement the search capabilities of the document store with the even richer search capabilities of OpenSearch. So we'll build an OpenSearch search index on the movies. Well, that's already three models, really. These are three different database services each with different ways of storing data, really different ways of modeling that data. But they're all connected. They're all storing the same thing. They're just storing it differently. And I need them all for my solution. Now, I also have in the bottom center a data lake. And why not? Data lakes are becoming pretty popular. So I may want to have the ability to do analytics on my data in a data lake. And so I might leverage AWS services like Lake Formation, Glue, and Athena. I may use a dashboard like QuickSight to slice and dice the data. And typically the storage for the data would be in S3. And so I'll have a data lake also. And in fact, I'll source my data from the Internet Movie Database, and I'll use ETL, or extract, transform, load. The data lake will be a source of data that actually feeds into the document store. So I'll have a data lake, and I also want a knowledge graph, which is shown on the right, kind of middle right. I'll build that on Amazon Neptune, and it will also take its data from the data lake. It will take that IMDb data through an ETL process. It will reference data from the movie document store. So the movies that are referred to in the knowledge graph actually occur in the movie document store. And it will also federate additional data that exists out there in Wikidata and DBpedia through federation. And then just to round out the model, perhaps phase 2, I would build some video analysis and story analysis. So the video analysis, the idea would be, let's say I actually have the movie videos, the MP4 videos for the movies that are in my document store. I want to build the capability to determine what's in those videos using AI analysis. And I'll use a fairly elaborate solution, but one which is actually packaged as a solution that I can use today to recognize celebrities, things, key phrases, and so on in my movies using AI services like comprehend, recognition, transcribe. And I'll gather all of those findings into a couple of different places. One will be S3, where I'll keep kind of the detailed results, and then a summary of the results in DynamoDB. And then finally, let's assume I have a collection of short stories available in PDF written by authors from the LA and Orange County area. And I want to determine what's in those stories, so I'll use comprehend to use kind of AI analysis of what's mentioned in the story, and I'll keep those results in S3. And the knowledge graph will tie all this together. The knowledge graph is interested in what's in the movie document store, as well as the video analysis and the story analysis. The reason for the story analysis, by the way, is that it turns out that many of these stories mention movies, which allows me in the knowledge graph to actually tie stories to movies in an interesting way. So if I want to build something like this, I really have to answer two questions. One is the what. How would I actually model all of this? The other is the how. How would I implement combined reads and combined writes, for example? So that won't be my focus today. It's always a topic I'm happy to elaborate on separately, but I want to focus really on the what. But in terms of the how, here's an example of a combined write that I might actually want to do. So I might have an application, and I might be interested in bringing together the various data that show me movies with a lot of continuity goofs in them. And so I might build this by, first of all, going to the document store. Step one would be to go to the document store to get the top 10 movies by the amount of continuity errors that they have in them. And since I'm using a cache, in step two, I would look for those movies in the cache first. And if I don't find them there, I'll go to the document store. And then in step three, I might gather together more information about those movies based on the relationships that are maintained in the knowledge graph, including going out to Wikidata and DBpedia through federation to get additional information about the movies. And then in step four, I would pull in any video analysis that I have for these movies. And in step five, I would pull any story analysis, stories that happen to mention these movies. I'll also bring in those results. So in terms of the what, how I would actually model this, we need an approach. We want a way to attack the problem. So as a data architect, I would want to produce an overall model that brings together each of these multi-models. And so I should divide the problem, I suggest, into a set of data products. I should really think of myself as delivering a set of data products that I would offer to consumers in a data mesh. And I should do so even if I'm not adopting data mesh, even if it's not on my radar. Just the framework abstraction of data product is a great way to get a hold on the problem. So even if I'm not adopting data mesh, if I just think of that I have an invisible data mesh and then I'm feeding products to it, that's good enough to get me thinking the right way about the problem. Additionally, I want to think of knowledge graph as being part of the problem. And so I want knowledge graph to be a place where I can actually maintain relationships between products well enough that if someone was interested in one product, I should be able to recognize the relationships it has to other products and thereby do a kind of cross sell. Say, if you're interested in this product, you may also be interested in these other products. It's probably the case if I were to adopt this approach that I am actually already adopting knowledge graph. And in fact, in my model, knowledge graph is serving two purposes. It's one of the models. It's also a way of asking questions about the overall multi-model approach. And in this scheme, my apps are really mesh consumers that ask the knowledge graph questions about how products relate to each other. So what I need to build into my model are, first of all, a list of products. And for each product, I need to know its name, its keys, its main attributes. I don't need to know the whole schema, but I need to know enough about the schema to answer relationship questions. And bear in mind that my schema may be in different forms. So my data may be inherently normalized. It may be document oriented. It may be semantic. So we need to keep each of those options open. And we want to keep it light. So we don't want to, we want to focus on the product view of the data rather than its intricate internal structure. But I want to be able to capture, in documenting these products, the relationships they have to each other. So whether a given product joins to another, refers to another, and so on. And I also want to be able to document any usage patterns, mappings, or validations that are pertinent to understanding the data product. And finally, I want to be able to tie the product to its implementation, which you'll see in a moment. I want to know what database service from the truck I actually used. And so there's different ways in which I could actually draw this. I'm going to show a UML approach, but there are alternatives I might use. I might actually build the product list as an ontology or use JSON LD or schema, for example. So the model is a helpful picture, but it's also not just a picture, but something that I could, is model driven. From a picture, I should be able to generate or build code. And so if I've drawn the picture right, I should be able to offer my data product to a mesh based on what I put in the picture. And also, if I have a knowledge graph, which I most certainly do in this solution, I can actually take what's in the picture and make it graph data that I can query so that I can understand, I can basically ask questions to the graph about the products that I have. And in fact, I have an underlying ontology in my approach describing how these products can be represented in a graph. So a tutorial which I have for you at the link shown here, please give it a try. In the approach, basically, as a data architect, you can use a UML modeling tool to document what all of your data products are as part of your multi-model solution. You could then, if you had a mesh, use what's in that model to publish your product to a data mesh. That's shown as a dashed line here because I don't actually build that in my demo. But then using basically a transformation that takes the UML and converts it to RDF, or resource description framework, we can then load the products into a knowledge graph based on Amazon Neptune. And once we have that, we can ask questions. So the data mesh, if it exists, could ask questions about how does this product relate to others. My apps could ask the same questions. And included in my demo is actually a Jupyter notebook that also issues Sparkle queries to ask questions about product relationships. So one example here, the story analysis, the way in which I rendered this in UML is to represent the data product itself called story analysis as a UML class. and then its implementation as another class. And I use stereotypes to indicate what these classes are doing. So story analysis actually is a data product. LA Orange Story Bucket is a data product impl. It's an implementation. And I actually tie it to the truck. So the LA Orange Story Bucket has a specified AWS resource and service. The service is S3, the resource is bucket contents. And you can see some additional detail here. So for example, story title is a product key for the story analysis. And here is a kind of a representation of how it would be translated to RDF. And in the interest of time, I won't walk through this in great detail, but at the link that I showed, you can see how this is actually constructed in RDF. And I'll also show briefly the knowledge graph, which is a model with products. So I actually have a movie resource product, a contributor resource product, a story resource product. So I have my knowledge graph has data products, but it also is the place where I put the overall multi-model. So it's serving two purposes, really. It's a place that I can ask questions about product relationships, and it's also a place where I can have particular movie relationships as data products. And underlying this, since I use UML, I need a mapping. So there's some, essentially I use annotations as a way to express relationships between classes. UML is not really an ideal tool for representing ontologies, so I don't even attempt to do so. UML's purpose here is really to document products and their relationships to each other. And for details, please take a look at this link. The tutorial will walk you through more details. And here's an example of a Sparkle query that I use in my tutorial to understand what are the data products that I have and what are the relationships to each other, and also what are their implementations. And I could actually ask more advanced questions like, is a story related to the Internet Movie Database? And through a sequence of steps, it turns out that it's true. It's a less than obvious connection that a story would actually be related to the Internet Movie Database. But because such relationship exist in my data products, I can actually answer in the affirmative. They are related. So to summarize and to wrap up, you probably need to build multi-model solutions. You should use a pattern like what I've described, break it down. You won't end up building a Rube Goldberg machine. Old school was great, but now you want to use what's actually on the truck and incorporate more services. And the approach that we've taken is to use the idea of data mesh assisted by knowledge graph. And there's my sample if you want to give it a try on your own. So thank you very much for your time today. And I'm just going to briefly turn to any questions. Why doesn't the bird go for the seeds is the only question, I think. I'll leave that to you, Matthew. I'm not sure the answer. Can we achieve the structure using CloudFormation? Yes, and that will be available soon. You can create all of this through CloudFormation. And if you're interested in building ontologies in UML, take a look at OntoUML. Great suggestion. Any additional questions while we wrap up? Well, I appreciate everyone's time. Please check out the demo, and I'm always happy to talk more on this subject with you. Thank you.